All right, so you've got the basics of Python down, but you're probably asking, how do I take my code to the next level? How do you make your program smarter, more efficient, and, well, more Pythonic? Today, we're diving into exactly that, the tools that let your code make decisions and repeat actions in a really elegant way. Let's get into it.
At its core, programming is all about controlling the flow. Just think of your program as being on a journey. At every step, it could hit a fork in the road. Does it go left? Does it go right? Does it just keep going straight? Control flow tools are basically the road signs that guide your program down the right path. So, the most fundamental tool in our entire kit is the if statement. It's that classic, if this thing is true, then do that thing. But of course, Python gives us a bit more to play with than just a simple yes or no.
And this brings us to a really key feature for writing clean code, elif. It's just short for else if, and this little snippet shows you exactly why it's so great. Instead of nesting if statements inside of other if statements, which gets messy fast, elif lets you check a bunch of different conditions, one after the other, in a nice, flat, readable way. It's just a perfect example of how much Python cares about clean code.
Okay, let's switch gears and talk about repetition. When you need to do the same thing to every single item in a collection, you're going to reach for a loop. And honestly, Python's for loop is just a masterclass in how to do it right.
So here's the crucial difference. In a lot of other languages, you have to manually create a counter, you have to increment it, you have to check it, and then you use that counter to grab the item. But Python? It just lets you work directly with the items themselves. I mean, look at the right side. For item in items. It practically reads like a sentence in English.
And here's that whole idea in action. We've got a list of words, and the loop just hands us each word one by one. We're not thinking about index 0, index 1, index 2. We're just thinking about cat, window, and defenestrate. The reason this works so beautifully is because a list is something we call an iterable.
So what even is an iterable? Really, it's any object in Python that you can loop over. It's a super fundamental concept. When a for loop sees an iterable, it just knows, hey, I can ask this thing for its items one after another until there are none left. It's this simple agreement that makes for loops so incredibly powerful across all sorts of different data types.
Basic loops are great, but, what if you need more control? What if you need to stop early or maybe skip an item? Or what if you need to run some code only if the loop finishes all on its own? Well, Python has you covered.
Now, this is one of Python's most unique and, let's be honest, most misunderstood features. Usually, we only care about what's happening inside the loop. But sometimes, the most important bit of information is whether that loop actually got to run all the way to the end without being stopped.
This code for finding prime numbers is the classic example. Let's walk through it. The inner loop's whole job is to find a factor for the number n. If it finds one, it prints the result, and then, boom, it hits break and exits that inner loop immediately. But what if that loop tries every single number and never finds a factor? If it finishes without ever hitting break, then and only then does the else clause run, and we can say for sure that n is a prime number. This is it. This is the key takeaway, the one thing that trips up so many people when they're starting out. Just look at the indentation in that last example. The else lines up perfectly with the for, not the if. This is a loop else, and it has a very, very specific job.
The best way to think of it is as a no-break clause. It's the code that gets to run when your search mission is over and you didn't find what you were looking for. It's actually a lot more like the else you see in a try-except block, which runs when there's no error, than the else in a regular if statement.
And real quick, let's talk about the pass statement. It does absolutely nothing. Seriously. So why does it exist? Well, sometimes Python's syntax demands a block of code, like inside a function or a class, but you haven't written that code yet. Pass is the perfect placeholder. It lets you sketch everything out and fill in the details later.
So we've been writing some pretty powerful logic, but it's all been kind of out in the open. The next step on our builder's journey is to package up that logic into reusable blocks that we can call whenever we want, and we do that by defining functions.
We do this with the def keyword. Right here, we're creating a function called fib2 that takes one argument, n. All the code inside calculates the Fibonacci series up to that number, and then the return statement sends the final result back. Now, anytime we need that series, we can just call fib2 instead of having to write all that logic all over again.
Basic functions are great, but the real power kicks in when you build functions that are flexible. Functions that can handle optional values, or maybe even a totally variable number of inputs.
Python gives us three main ways to achieve this. We can set up default values for our arguments, we can let people pass in arguments by name using keywords, and we can even create functions that just accept any number of arguments thrown at them.
But first, a huge warning. This is a classic gotcha. The default value for an argument, it gets evaluated only one time, right when the function is first defined. So if you use something mutable like a list, every single call to that function will be sharing and changing the exact same list. It leads to some really weird bugs. The solution, the right way to do it, is to default to none and then create a new list inside the function if you need one. Trust me, learning this is a rite of passage for every Python developer.
Next up, T-word arguments. This just lets you pass in arguments by name, like you see in the parrot example. This makes your function calls incredibly clear because you don't have to memorize the exact order of the parameters. As long as they come after any regular arguments, you're good to go.
So what if you have no idea how many arguments you're going to get? That's what args and double star quarks are for. That little star, args, scoops up any extra positional arguments into a tuple. The double star quarks does the same for keyword arguments but puts them in a dictionary. The example here uses args to let us join together any number of strings we want. It just gives our functions ultimate flexibility.
So let's do a quick recap of our new toolkit. We have if, elif, and else for making decisions. We have for loops to go over any sequence, range to create number sequences, and break and continue to boss our loops around. We've got that special for else for when a loop finishes normally, and we can wrap all of it up into super flexible functions using def, default arguments, and of course args and quargs.
Phew, that was a pretty quick tour, but hopefully it gives you a much better feel for some of Python's most powerful control flow tools. If this explainer helped you out, please make sure to subscribe and hit that like button so you don't miss the next one. And for more tutorials on Python and a ton of other languages, go check out www.plus2net.com.
You've just added some serious gear to your programming toolkit. So the only real question left is, what are you going to build with it? What problem can you solve now, but in a much more elegant way? Thanks for watching.